I'm Jared Campo, and this is my presentation on the extraction, oxidation, reduction, and spectral characterization of myoglobin in crude lysate. So a little background on myoglobin. Myoglobin is a protein found in the muscle of vertebrates, and it can be found in mostly striated muscle and in cardiac muscle. However, it is present in scarce amounts in smooth muscle. Vertebrates use this as an oxygen storage site in muscle tissue, and myoglobin can exist in 4 different states, and one of which is oxymyoglobin, another being deoxymyoglobin, metmyoglobin, and carboxymyoglobin. And to the right, there's an image of myoglobin in the ferrous state, in the Fe2+ state. So the objectives in this lab were, 1, to prepare the samples of myoglobin and oxymyoglobin. Next, we wanted to observe the effects of heme oxidation state in respect to UVIS, which we would expect to give different absorbance values at different wavelengths. And then lastly is to determine the relative concentrations of the iron in our myoglobin samples, whether that being in the reduced form or the oxidated form. So after treating our homogeneous samples with potassium ferrocyanide and then in separate vials with sodium dithionate, we found these results, and to the left is a table that shows the absorbance values at those specific wavelengths via the UVIS, and figure 2 to the right is showing the concentrations of iron in the oxidized form versus the reduced form for those mixtures. So that brings us to the discussion of the results. And essentially what the results showed is that potassium ferrocyanide acts as an oxidizing agent, while the sodium dithionate acted as a reducing agent. And this correlates with the data where you see the highest wavelength of potassium ferrocyanide at 409 nanometers, which is known from past research to be where the peak is when iron is in the oxidized form. And sodium dithionate acted as the reducing agent, and that correlates to its highest peak, which was at 417 nanometers, and the past research supports our findings. Now we can draw some conclusions about our results, which would be that SDT is in fact a reducing agent, and we found when myoglobin is mixed with STD, there is more iron found in the Fe2+ state, or the reduced state. And the opposite holds true for when myoglobin is mixed with potassium ferrocyanide, and we found more iron in the oxidized form, which is the Fe3+. However, there is a lot of controversy whether or not iron actually reaches the Fe3+ state. There is the argument being made that it only reaches an Fe2+ state in intermediate spin. So this is something that we could look to cement further in the future. So thinking of ways where we can extend our future research and our findings is exploring other sources of myoglobin. We tested a beef homogenate, which was with striated muscle. However, myoglobin can be found in cardiac muscle and even in smooth muscle in small amounts. So perhaps researching myoglobin extracted from those regions of the body. And also using different animals and seeing how myoglobin is different throughout the different species.